So let's take a look at this worked example before moving on to the class example. A conversation between two people in a park measures 55 decibels. A jackhammer nearby measures 104 decibels. How many times as intense is the sound of the jackhammer? Okay, so solution would just be to first convert each measurement to bells. So instead of being 55 decibels, it's going to be 5.5. We just move the decimal place over one to the left. And a jackhammer, instead of being 104 decibels, would be 10.4 bells. Then express each as a power of 10. So in the end, 10 to the power of the louder one, the jackhammer, so 10.4 minus 5.5, the conversation, is equal to, and that just tells us right away, 79,433 times as intense. So now let's look at the next part. Okay, now let's look at class example 3.68. Determine how many times as intense the sound of a lawnmower is at 82 decibels compared to leaves rustling in the wind at 48 decibels. So if we have 10 to the power of B1 minus B2, that's going to tell us how many times as intense it is. Now just careful, because this B1 and this B2 needs to be in bells and not decibels. So let's rewrite each of these. So 48 decibels as 4.8 bells and 82 decibels as 8.2 bells. So then 10 to the power of 8.2 minus 4.8, it's going to be 2,512 times as intense. Okay, so now let's look at the next one. It says determine the decibel level of a power tool that has 375 times the intensity of sound of the lawnmower. So now in this case, they've given us how many times as intense it is. This is going to be similar to one we did with the Richter scale as well, when it was how many times as intense was the earthquake. So this one's how many times as intense is it. So the first B value is going to be the bell measure of the louder sound. The second one would be the bell measure of the other sound. So in this case, we don't know the louder sound. But then the other sound is going to be 8.2. And then we know whatever that works out to, we know that it's going to be 375 times as intense. So then in this case, we just have an exponential equation to solve for. We need to get that x out of the exponent. So we're going to use logarithms. So let's just convert this to logarithmic form. So base 10, so we're going to use log base 10 of 375, and then that's equal to x minus 8.2. And then just add 8.2 to both sides. And we get that x is approximately equal to 10.8. And now just careful here, because we need to remember that we were actually measuring in bells when we did it this way instead of decibels. So we just need to change that back to 108 decibels.